Behind the walls of their training compound near Beijing, the Special Combat Brigade conducts exercises so realistic that soldiers practice urban warfare drills in full-scale subway replicas and high-rise building assaults. Modern simulation systems create scenarios that test every aspect of special operations warfare. These men train for missions they hope never to face, but must be prepared to execute perfectly. We documented their current training cycles and discovered their real-world mission record remains closely held by the PLA, but recent joint exercises indicate growing operational readiness. The transformation of this elite unit reflects broader changes in how China selects and prepares its most capable warriors for an evolving battlefield. The new generation recruitment drive. Recruitment centers across Beijing now buzz with activity that would have seemed impossible during the brigade's formation decades ago. In 2025, candidates include tech graduates and former athletes side by side, reflecting the PLA's expanded criteria. Computer science graduates sit alongside martial arts champions in waiting areas, each carrying portfolios that showcase drastically different skill sets. A 23-year-old software engineer from Tsinghua University reviews cybersecurity protocols, while the candidate next to him practices advanced combat breathing techniques. This scene repeats daily as the brigade searches for individuals who can master both digital warfare and physical combat operations. Modern warfare demands have transformed the candidate profile completely. The traditional recruitment focus on physical strength and rural backgrounds has expanded to include urban professionals with advanced technical degrees. Software engineers who spent years developing artificial intelligence algorithms now compete for positions alongside former police officers and military veterans. The selection committee reviews applications from individuals with backgrounds spanning technology, engineering, and specialized athletics. Each candidate must demonstrate proficiency in multiple domains that reflect the complex nature of contemporary military operations. The screening process itself has become a technological showcase that rivals the training these candidates hope to receive. Advanced physiological sensors track stress responses during physical examinations, while algorithms analyze psychological profiles in real time. Candidates wear monitoring equipment that measures cardiovascular responses and stress indicators during simulated combat scenarios. The data collected creates comprehensive profiles that predict performance under extreme conditions with remarkable accuracy. These systems can identify candidates who might excel in traditional training but struggle with the technological integration required for modern operations. Statistical analysis reveals the dramatic shift in selection standards. Today, only a small fraction of volunteers succeed, compared to earlier decades when physical fitness and basic military aptitude were sufficient qualifications. Current screening protocols eliminate candidates who cannot demonstrate rapid learning capabilities across multiple technical disciplines. The selection committee reviews applications from tens of thousands of individuals annually, yet only hundreds of positions become available. This creates intense competition that drives candidates to develop hybrid skill sets, combining physical excellence with technological expertise. Recruitment officers have expanded their search parameters to include locations that previous generations would have ignored completely. University campuses host specialized recruitment events where officers demonstrate advanced equipment to computer science and engineering students. Technology companies receive regular visits from brigade representatives who seek employees with both technical skills and physical fitness backgrounds. These recruitment drives target individuals who might never have considered military service, but possess the analytical thinking required for modern warfare applications. The officers present military service as an opportunity to work with cutting-edge technology that exceeds anything available in civilian sectors. The cognitive assessment process has become as rigorous as physical testing. Virtual reality systems create high-stress scenarios where candidates must make split-second decisions while processing multiple information streams simultaneously. These assessments measure pattern recognition, spatial reasoning, and decision-making speed under extreme pressure. Candidates navigate complex urban environments while identifying threats, coordinating team movements, and managing technical systems. The scenarios adapt to individual performance levels, creating increasingly difficult challenges that push cognitive abilities to their limits. Performance data from these assessments often determines selection outcomes more than traditional physical fitness scores. Demographic analysis shows the average successful candidate age has increased to 24 years, reflecting the extended education requirements for technical specializations. Most accepted candidates hold university degrees in fields directly applicable to modern warfare, including computer science, electrical engineering, and applied mathematics. This age increase creates challenges for traditional military discipline structures designed for younger recruits. The brigade has adapted its training protocols to accommodate candidates with established professional backgrounds and advanced analytical skills. These older recruits often bring workplace experience that enhances team dynamics and problem-solving capabilities. Geographic recruitment patterns have shifted dramatically toward urban centers where technical education is more prevalent. Cities like Shanghai, Shenzhen, and Guangzhou now provide more successful candidates than traditional rural recruitment areas. Urban candidates typically possess stronger educational backgrounds and greater exposure to advanced technology, making them better prepared for the technical aspects of modern training. However, they often require additional physical conditioning to meet combat standards. The brigade has established partnerships with urban fitness centers and martial arts schools to help prepare potential candidates before they apply. The waiting list system demonstrates the unit's selectivity and the intense competition for positions. Thousands of qualified applicants remain on active waiting lists, with some individuals maintaining their applications for multiple years while improving their qualifications. The brigade maintains detailed profiles of waiting list candidates, tracking their continued education, physical fitness improvements, and skill development. Some candidates complete additional certifications in cybersecurity, learn multiple programming languages, or pursue advanced degrees to strengthen their applications. This waiting period often results in better prepared candidates who demonstrate exceptional commitment to joining the unit. Competition among candidates has created unofficial preparation networks where potential recruits share training strategies and technical knowledge. Online forums discuss the latest selection criteria, physical training regimens, and technical skills that might provide advantages during the application process. Some candidates form study groups to master advanced mathematics, cryptography, and systems analysis. Others focus on developing hybrid fitness programs that combine traditional military conditioning with technical training. These preparation networks demonstrate the high level of commitment required even to attempt joining the brigade. The transformation extends beyond individual qualifications to encompass the entire recruitment infrastructure. Advanced data analytics help identify potential candidates from academic records, professional achievements, and demonstrated problem-solving abilities. The recruitment system can predict which individuals might succeed in training based on educational background, extracurricular activities, and analytical capabilities. This predictive capability allows recruiters to focus their efforts on candidates with the highest probability of success, making the entire process more efficient. Training preparation programs have emerged to help candidates develop the hybrid skill sets required for selection. These programs combine physical conditioning with technical education, creating intensive preparation courses that can last 6 months or longer. Candidates learn basic programming, electronics theory, and systems analysis alongside traditional military fitness training. Some programs include simulated selection exercises that help candidates understand the expectations and prepare for the actual screening process. The existence of these preparation programs reflects the complexity of modern selection requirements. The evolution in recruitment represents a fundamental shift in how China approaches special forces development. The brigade now seeks individuals who can operate effectively in both physical and digital warfare environments. This dual capability requirement has created a new category of military professional that combines traditional warrior skills with advanced technical expertise. Once selected, these carefully chosen candidates face training that pushes both their physical and technological capabilities to unprecedented levels. Advanced Training Technology Revolution. The main training hall stretches across 2 football fields, filled with equipment that appears more suited for a technology showcase than a military base. Virtual reality systems create 3-dimensional combat environments that materialize around soldiers within seconds. These simulations generate enemy combatants that move, react, and adapt to soldier behavior with remarkable realism. The virtual opponents use artificial intelligence programming that learns from each encounter, developing counter-tactics that challenge soldiers in ways human instructors never could. During one observed session, virtual enemies remembered individual soldier movement patterns from previous exercises and adjusted their positioning accordingly. The soldiers wear specially designed training suits embedded with sensors that monitor physiological responses throughout each exercise. These sensors track heart rate patterns and stress levels while soldiers navigate combat scenarios. The data streams directly to instructor workstations, where real-time analysis reveals how each soldier responds to different stress factors. Instructors can identify which scenarios cause the greatest physiological impact and adjust training intensity accordingly. The sensor data also reveals which soldiers maintain optimal performance under extreme stress and which require additional conditioning. Adjacent to the main hall sits the Virtual Reality Combat Laboratory, a facility that can transform its environment to match any location on Earth within minutes. The laboratory uses advanced climate control systems and acoustic manipulation to create complete sensory experiences. Soldiers train in simulated Arctic conditions where surfaces become genuinely slippery with artificial ice and temperatures drop to match real polar environments. Minutes later, the same space becomes a tropical jungle complete with humidity and vegetation sounds. Urban warfare scenarios include realistic traffic noise and the visual complexity of crowded city streets. The artificial intelligence opponents represent the most sophisticated aspect of the training system. These virtual enemies analyze soldier tactics during each encounter and develop new strategies for subsequent sessions. The AI can recognize individual soldiers and remember their preferred combat approaches, forcing each trainee to continuously evolve their methods. During observed training, the AI opponents demonstrated advanced tactical knowledge, using cover effectively and coordinating group movements. The system creates increasingly difficult scenarios as soldiers improve, ensuring that training never becomes routine or predictable. Advanced simulators track performance metrics throughout each exercise session. The system monitors soldier movements, weapon handling, and tactical decisions with remarkable precision. This data allows instructors to analyze combat techniques and identify inefficient movements or tactical errors that might prove fatal in real operations. The system can compare individual soldier performance to established optimal patterns and provide specific feedback for improvement. Video analysis sessions show soldiers their own movements alongside demonstrations of perfect technique. Environmental chamber systems replicate extreme conditions that soldiers might encounter during actual operations. These chambers can simulate temperature extremes ranging from Arctic cold to desert heat within controlled timeframes. Soldiers practice equipment maintenance, weapon operation, and tactical movements under conditions that test both physical endurance and technical proficiency. The chambers include altitude simulation capabilities that prepare soldiers for high elevation operations, where oxygen levels affect performance significantly. High-tech firing ranges incorporate scenario-based training that goes far beyond traditional marksmanship practice. These ranges create complex tactical situations where soldiers must engage targets while navigating obstacles, coordinating with team members, and processing multiple information streams simultaneously. The ranges can simulate urban environments, rural terrain, and industrial facilities with remarkable accuracy. Targets appear and disappear based on programmed scenarios that test decision-making speed and accuracy under pressure. Combined Arms live-fire exercises integrate multiple weapon systems and tactical approaches in realistic combat scenarios. These exercises require soldiers to coordinate infantry movements with supporting elements while engaging targets across varied terrain. The training incorporates communication challenges, equipment malfunctions, and time pressure that mirror real operational conditions. Soldiers must demonstrate proficiency with multiple weapon systems while maintaining tactical awareness and team coordination. GPS-DENID navigation training prepares soldiers for operations in environments where satellite communication is unavailable or compromised. These exercises require soldiers to navigate using traditional methods while maintaining mission objectives and team coordination. The training includes urban environments where tall buildings block satellite signals and rural areas where electronic warfare might disrupt communication systems. Soldiers learn to operate effectively using map reading, compass navigation, and terrain recognition skills. The integration of these technologies has transformed training efficiency in measurable ways. Training duration for specific skills has decreased significantly compared to traditional methods, while skill retention rates have improved substantially. Soldiers demonstrate better performance consistency across varied scenarios and maintain their skills longer between training sessions. The technological approach allows for precise measurement of improvement rates and identifies specific areas where individual soldiers require additional focus. Instructors operating these systems require extensive technical training beyond traditional military expertise. They monitor multiple data streams simultaneously while managing complex simulation parameters and analyzing real-time performance metrics. The instructor workstations resemble command centers more than traditional training oversight positions. These instructors can modify scenarios instantly based on soldier performance, creating customized training experiences that address individual weaknesses or build upon existing strength. The facility operates continuously with different training scenarios running simultaneously in various sections. Advanced soldiers train alongside newer recruits, but in separate environments that match their skill levels appropriately. The system can accommodate multiple training objectives simultaneously, from basic marksmanship improvement to complex multi-team coordination exercises. This flexibility allows the brigade to maintain continuous training cycles without scheduling conflicts or resource limitations. Data collection from these training systems provides unprecedented insight into Special Forces performance patterns. The brigade maintains detailed performance databases that track individual soldier improvement over time and identify which training methods produce optimal results. This quantitative approach to training assessment removes much of the subjective evaluation that characterized previous training methods. The psychological impact of training with such advanced technology extends beyond skill development. Soldiers report increased confidence when facing real-world scenarios because they have experienced similar situations in training environments that felt completely authentic. The technology also reduces the psychological barriers associated with combat stress, as soldiers become accustomed to maintaining performance under simulated extreme conditions. These sophisticated training systems require equally advanced equipment to maximize their effectiveness. The technology that soldiers use during these exercises must match the complexity of the scenarios they face. Next-generation equipment arsenal. The equipment room resembles a technology showcase more than a traditional military armory. Soldiers select gear that incorporates advances in materials science and domestic manufacturing capabilities. Each piece of equipment represents years of research and development aimed at creating tactical advantages that previous generations could never have imagined. The transformation from conventional military gear to these advanced systems reflects a fundamental shift in how special forces approach combat operations. The standard uniform now functions as an integrated communication platform. Advanced fiber materials woven directly into the fabric create communication pathways that connect various systems seamlessly. These materials transmit data throughout the uniform, linking sensors, communication devices, and monitoring systems without external equipment. The fabric itself contains processors that manage information flow and power distribution across the entire system. Soldiers can communicate with team members, receive tactical updates, and monitor their own physiological status without carrying visible electronic equipment. Health monitoring capabilities built into the uniform provide continuous medical surveillance during operations. Embedded sensors track heart rate, blood pressure, body temperature, and hydration levels in real time. The system can detect early signs of heat exhaustion, dehydration, or injury before symptoms become apparent to the soldier. Medical data transmits automatically to command centers where doctors can monitor soldier health status and provide immediate guidance for field treatment. The uniform can even alert medical personnel when soldiers require immediate attention based on physiological indicators. The QBZ-95 assault rifle family represents the backbone of the brigade's personal weapon systems. Enhanced versions of this domestically produced platform incorporate advanced optics and targeting systems that improve accuracy across varying combat conditions. The weapon features modular components that allow rapid reconfiguration for different mission requirements. Environmental sensors built into the system compensate for temperature changes that affect performance, maintaining reliability across diverse operational environments. The rifle's design reflects years of domestic development aimed at reducing dependence on foreign weapon systems. Advanced sniper systems like the QBU-10 incorporate thermal scopes that provide enhanced targeting capabilities in low-light conditions. These weapons feature precision-engineered barrels and advanced optics that extend effective engagement ranges significantly beyond previous generation systems. The thermal imaging capabilities allow snipers to identify targets through smoke, fog, and darkness with remarkable clarity. Ballistic computers integrated into the scope systems calculate range, wind speed, and environmental factors automatically, providing targeting solutions that improve first-shot accuracy rates. Specialized underwater rifles serve the brigade's marine mission requirements. These weapons function reliably in aquatic environments where conventional firearms would fail completely. The underwater rifle systems use specially designed ammunition that maintains effectiveness beneath the surface while providing adequate stopping power against targets. These weapons represent unique domestic manufacturing capabilities that address specific operational requirements for amphibious special forces missions.